Hello, my dear students. Myself, Devi Prasad Sir, welcomes to you all to the chemistry class. Today, I will explain you all about the remaining portion of the chapter Elements, Compounds and Mixtures. Mixture. A mixture is made up of two or more elements or compounds mechanically mixed together in any proportion such that its properties are that of its components. Now, coming to the characteristics of mixtures. The first one, in a mixture, the components can be mixed in any proportion by weight. Hence, the mixture may not be homogeneous. Coming to the second point, the individual components of a mixture retain their original properties. For example, iron is attracted by a magnet and dissolves in acid when mixed with sulfur. Coming to the third point, the components of a mixture can be separated by simple physical means. For example, in a mixture of iron and sulfur, iron can be pulled away by a magnet, or sulfur can be dissolved out by a solvent called as carbon disulfide. No energy change is involved in the preparation of a mixture. Energy changes takes place during the formation of a compound. For example, a candle burns to form carbon dioxide and water vapor and liberates heat and light energy, which is an example of exothermic reaction. And another example is that during the process of photosynthesis, carbon dioxide and water combine to form glucose by absorbing light energy. It is an example of endothermic reaction. Now, the important differences between mixtures and compounds. Mixture. When iron fillings and sulfur are mixed in a watch glass, you can still see the black specks of iron and the yellow sulfur powder, whereas in a compound, when a mixture of iron and sulfur is heated, a black shiny compound, iron 2 sulfide FeS, is formed. Coming to the next point, when a magnet is brought near this mixture of two elements, the iron fillings are pulled away and stick to the magnet. Sulfur remains in the watch glass, whereas in case of the compound, when the magnet is brought near it, the iron of the iron 2 sulfide remains unaffected. Now, coming to the third point of mixture, if an acid like hydrochloric acid HCl is added to the mixture of iron and sulfur, a colorless, odorless gas hydrogen is evolved, which burns with a blue flame and is extinguished with a pop sound. Whereas in case of a compound, when the acid HCl is added to the compound iron 2 sulfide, a colorless gas with the smell of rotten egg is evolved. This gas is nothing but hydrogen sulfide. Now coming to the next point. If carbon disulfide, that is a liquid, is added to the mixture, sulfur dissolves but iron does not dissolve in it. And in case of the compound, if carbon disulfide is added to the compound, then iron 2 sulfide does not dissolve but sinks to the bottom of the test tube. Mixture do not have a sharp melting and boiling points, whereas compounds possess sharp melting and boiling points. And in case of the mixture, formation of a mixture is not accompanied by energy changes, but in case of the compound, usually compound formation is accompanied by energy change in the form of heat, light, etc. Now, types of mixtures. Solids, liquids and gases can all be mixed in different combinations. Mixtures are found in two forms, homogeneous and heterogeneous. For example, Liquid mixtures can be of oil and water, in which the two liquids do not mix. Such mixtures are called heterogeneous. On the other hand, alcohol and water mix easily. They are said to be miscible, and the mixture is said to be homogeneous. Now the type of mixture, solid plus solid. The technique to separate, hand picking, use of magnet, sublimation, use of suitable solvent plus filtration, and finally fractional crystallization. Now hand picking. If the components are of different sizes and color, then this method is employed. If one of the components of the mixture is a magnetic material, example iron and sawdust, then iron is attracted by a magnet. For this purpose, use of magnet technique is employed. Now, if one of the component of the mixture sublimes, that's for example iodine plus salt, then iodine sublimes on heating, then the technique of separation sublimation is followed. Next, if one of the components dissolves in a particular solvent, the undissolved solid is separated by filtration. In that case, use of suitable solvent plus filtration is followed. And finally, if both solids are soluble in a common solvent, then each component crystallizes at different temperatures. Example, a mixture of sodium chloride and potassium nitrate. In that case, fractional crystallization process is followed. Now, solid liquid mixture. The different techniques used are filtration, sedimentation and decantation, evaporation and distillation. Now, if the solid is insoluble in the liquid and the solid is lighter and floating, example, sawdust plus water. Sawdust floats on water. Then the process of filtration is used to separate the mixtures. Next, the solid is insoluble in the liquid and being heavy settles to the bottom forming a sediment. Then the upper clear liquid is the liquid which can be separated by the process of sedimentation and decantation. Now, the process of evaporation is followed if one of the components is a non-volatile soluble solid. Only the solid component is recovered and the loss of water can be ignored. And finally, if one of the components of the mixture is a soluble solid and both components are recovered, for that purpose, the technique of separation distillation is used. Liquid-liquid mixture. The techniques of separation are by using the separating funnel, fractional distillation. Now, based on the difference in densities, the lighter liquid forms upper layer, the heavier lower liquid is run off from below. Example, oil plus water. And the method fractional distillation is followed depending on the difference in boiling points. The liquid with lower boiling point boils off first. Example, alcohol plus water. Now coming to the gas-gas mixture. The techniques used are diffusion through porous spot, dissolution in suitable solvent, and preferential liquefaction, and finally fractional evaporation of the liquefied mixture. Now, the first technique is used when the lighter gas diffuses out first, leaving behind the denser gas. For example, hydrogen plus carbon dioxide. Hydrogen is lighter. Now, if one of the gas is soluble in a particular solvent while the other is not, then dissolution in suitable solvent technique is employed. Now, preferential liquefaction technique is used if certain gases are easily liquefied. And finally, the fractional evaporation of the liquefied mixture is used if the liquefied gas components have different boiling points. For example, liquid nitrogen minus 196 degrees Celsius and liquid oxygen is minus 183 degrees Celsius, so that liquid nitrogen can vaporize first. Now, the liquid gas mixture. The technique used is heating. Solubility of a gas in a liquid decreases with increase in temperature. Example, sulfur dioxide and water. Then chromatography. Chromatography is a modern technique of separation of a mixture of substances based on the difference in the absorption of different substances on the surface of a solid medium. Now, the advantages of chromatography. Number one, it requires a very small amount of the substance or sample. Second one, the components retain their individuality during the process of separation. Third one, it finds application in easy separation of substances with similar physical and chemical properties. Dear students, I hope that you all understood the contents of this video. Please go through the lesson from your textbook again and again. Now, thank you for watching and learning from this video.